The timer counter type E is an accurate, precise 16-bit timer, and together with the waveform extension, the peripheral could be used for event counting, signal generation, and even motor control. Hi everyone, I'm Nilo, and today we'll be looking at the TCE NVEX. First, we'll go through what the TCE can do, and then we'll see how the waveform extension complements the TCE, and at the end we'll see the TCE and waveform extension in action by spinning a motor. In front of me here we have the C-Nano AVR EB, which we will be using today to showcase what the TCE and waveform extension can do. The TCE has four main modes of operation: normal mode, frequency generation mode, single slope mode, and dual slope mode. All of these modes can be used with the TCE's high resolution mode. In high resolution mode, we can increase the duty cycle's resolution by 4 or 8 times the normal amount. This mode is perfect for applications that require more precise timing and/or signal generation. The TCE has double buffered registers. What this means that instead of writing to the register directly, you write to a buffered register. The TCE waits until the clock resets and then automatically updates the respective registers. The double buffered registers are useful if you want to avoid unwanted wraparound and achieve glitch-free waveforms. So you can update those buffered registers whenever you are in your program. The TCE also allows for fractional values. So instead of writing an absolute value for the compare register, we can actually just write a fractional value in Q format, and the TCE will actually produce that said duty cycle. So let's say we want to produce a 70% duty cycle, we can just write 0.7 into the register, and the TCE will produce a 70% duty cycle. In addition to the compare register, the TCE also has the amplitude and offset register. These allow an extra level of control for the waveform. So let's say we have a sinus signal using a lookup table and a low pass filter. Now if we want to change the amplitude of the signal, instead of trying to recalculate the lookup table, we can simply change the amplitude register and change the amplitude of the signal. Therefore, we can reduce software complexity thanks to the amplitude and offset register. The TCE waveform outputs are directly connected to the waveform extension's inputs, where the waveform extension can provide extra capabilities to the waveform outputs from the TCE. The waveform extension can produce an inverted signal of the original waveform, essentially doubling the amount of PWM signals you can produce, from 4 to 8, using a single timer. Here you can see that I'm currently using only one compare channel. And on the oscilloscope, you can actually see that there are 2 PWM signals being generated, where one of them is inverted. The waveform extension also has built-in dead time units. This means that we can insert dead time into the original signal and the inverted signal to create a non-overlapping signal. This is useful when you're controlling H-bridges to avoid shoot-through. And by having it built into the hardware, we can reduce program complexion and secure protection. The waveform extension also has a mode called pattern generation mode. Now in this mode, the user is allowed to override the output pins of the waveform extension. Therefore, the user can override a single pin into either high state or low state, while other signals can continue. This mode is very useful if you want to make specific patterns. For example, if you want to spin a BLDC in a 6-step commutation, you can make those individual steps in this pattern generation mode. Moreover, the waveform extension also has a feature called fault protection. In fault protection, the program can drive all the output pins into a predetermined state. A fault is triggered by either software or an event system on the microcontroller. Fault protection is useful when something isn't going as planned. For example, if we have a motor stalling, the program can drive all those output pins down to low. Now, one of the main use cases for the TCE and waveform extension is spinning and driving a 3-phase BLDC motor. So here we have the AVR EB connected to the multi-phase power board, which is going to spin the BLDC inside this box, which is then going to spin this Microchip logo. And using our motor control library and its example code, I can spin the motor with a push of a button. And if you want to spin this exact motor right now, you can head over to try.microchip.com, where you can spin it online right now and see the TCE and waveform extension in action. Just head over to the description, or you can Google Microchip Try. As you have hopefully learned in this video, the TCE and NVEX are powerful peripherals that have additional capabilities such as dead time insertion and pattern generation mode. These features ultimately reduce the program complexion and CPU overhead. If you have any other questions, please leave them in the comment section down below. And if you want to learn more about the TCE and UX, head over to the description where you can find resources like application notes, demos, source code, and so much more. Thanks for watching.